Hello, hello, hello. Here we are doing exponent laws. Now, in the question we said, what do you think you remember were the parts of the exponent? Well, if we're dealing with exponent laws, let's think about the parts first of all. Okay? The first one we want to think about is drawing the following. The parts of the exponent are as follows. When you look at the 7x to the third power, what that tells you is that you've got a 7x to the third power, which is 7 times x, which is a variable, to the third power. So the third power, we can see, is the exponent. The whole thing is called a term. So 7x to the third is called a term. Once we finish that, then we can say, okay, what about the 7? What does it mean? Well, the 7 basically means it is a constant or numerical coefficient. Right there. Constant or numerical coefficient. The variable is x, and it can also be considered the literal coefficient. Notice that numerical coefficient means number, literal means letter. Okay? So that's an easy one to remember. So now those are the parts of the exponent. Numerical coefficient. Sorry, I got my things backwards here. Numerical coefficient, literal coefficient or variable, exponent, and finally, the term. The whole thing is considered the term. All right. So what happens when we want to basically look at it from the point of view of same base exponents, the base, which is the x or the variable, same base exponents, and we're going to multiply them together. Let's take a look. So what we've got here is we've got multiplication of powers with the same base. So as you can see, p is the power, or is the base, pardon me. So p is the base. So as we look at the p, we can see that we're multiplying those powers together with the same base. So we see p to the fourth times p to the third. Once we see p to the fourth and p to the third, we look at the base as being something that carries through. So the base carries through, and all we do is we add the exponents. We take the 4 from the first exponent, we take the 3 from the second exponent, and we add them together. So we end up with p, 4 plus 3 equals p to the 7th. That sounds way too easy, but it is. P to the 4th times p to the 3rd equals p, 4 plus 3, which is p to the 7th. Now remember, they have to be same base. Must be same base. Okay? Must be same base. All right. So now that we've taken a look at multiply, what do you think divide would be? If multiply was add, divide must be subtract. You're right. So when we divide those powers with the same base, what we're doing is we're subtracting the exponents. So once again, we have the same base, which is r and r. Okay? We take r divided by r to the 9th, divided by r to the 5th. That gets us r, 9 minus 5, which is r to the 4th. Same base exponent, subtract the exponents when we divide. So r to the 9th divided by r to the 5th equals r, 9 minus 5, which is r to the 4th. Subtract the exponents. All right, what I'd like you to do is I'd like you to take a look at it and come up with 3 of each. 3 multiply, same base exponents. 3 divide, same base exponents. Pretty straightforward. Go for it.